Okay, I can see it's already 9 o'clock, so welcome everyone at this SDC webinar. Today the topic will be how to reduce offshore validation time by 50%, automate loadings and multi-standard compliance with use of SDC Verifier. My name is Michal Oleksy. I'm a structure engineer and application engineer at SDC Verifier. And today I would like to tell a couple of words and show you a couple of useful tips how you can reduce your offshore validation time with use of our software. Let's move on to the agenda. By the way, during the whole presentation, our chat will be active, so you can type any question in any time of the webinar. So please feel free to type it. We will review it at the end of the webinar and try to answer all of them. So starting with agenda today. Of course, I would like to introduce you to some challenges during offshore structural validation. I will explain and focus also on some key pain points during offshore validation workflow, such as environmental loads, fatigue, buckling assessments. What are the limitations of manual verification? So when we do all those steps in, let's say, traditional way with piece of paper or some spreadsheets, and how to what we should compliance with. So all the standards for all the different kinds of offshore structures which we need to comply with. Then I would like to show you also how we can automate the verification workflow, automate all very time-consuming steps like load application for all different conditions, or the structural checks depending on different standards, and in general how to comply with all the different standards and how to verify them. Then at the end I will sum it up and of course say a couple of words about how we can implement it also in your company and in your workflow. And at the end, as I mentioned, we will have short Q&A session. So also feel free to drop any question in our chat. We will review it at the end. Okay, let's start. A couple of words of introduction about the company itself. We are SDC Verifier company, and our firm is built out of two departments. One of them is a department which develops simulation and structural verification software, which is SDC Verifier. And the second part of our team works as structural engineers. So we do not only have an experience in developing software, we also test this software on a daily basis. We use it every day, test it. So we always try to implement some new features based on our experience. And as you can see, at the moment we have more than 30 people in 3 offices in 3 different countries. More than 200 companies are already using SDC Verifier software, which results in more than 1,000 happy users. We work in multiple industries, and what is also important, we have our software which works independently with Nastran Solver, but also we have add-ons to popular FEA softwares like FEMAP, ANSYS, or SimCenter 3D. Regarding our structural engineering consultancy, we are working on different kinds of projects since 26 years already. We did more than 250 projects and more than 100 happy customers all over the world. Okay, let's start with our main topic, so offshore structure validation. As you know, all offshore structures are prone to various, they are exposed to a range of different environmental conditions like wave, wind, and all the conditions which are acting repetitively. It's not so simple to add all those different scenarios include all those different scenarios into your calculations if you do it manually. So I would say the only proper way to get an accurate results would be to use software such as SDC Verifier, where all those different scenarios can be easily implemented. Then, in order to ensure that the structure is safe and can be operated for amount of time which we assume for it to operate, we should take into account all kind of multiple failure modes, like failure due to fatigue, buckling, for example, and so on. So all of those different conditions have to be analyzed, and moreover, all those structures should comply with different industry rules depending also on the country, on the type of the structure, and so on. Then what I would say last major issue with modeling of those structures is the FEM model complexity. So a lot of the structures are complex. There are different elements. We model them with different types of elements also. So shell structures, beam structures, some very detailed parts with solids. So all of them should be combined sometimes into one model and analyzed with the same standards, which is often quite, I would say, tough to do with our standard approach. If we go into depth into all of those pain points, which I mentioned. So first of all would be environmental loads. We have different type of environmental loads, such as buoyancy, so our water pressure acting on a structure. So for example, for floating structures, floating platforms, ship hulls, and so on. Then tank water levels, so tank ballast, which is basically the fluid level based on the mass, which is transferred into pressure onto the surfaces which we model. Then one of the also most serious loads which acts on offshore structures and any kind of structure, I would say, is the wind load, where we should consider exact value of wind load depending on the height, depending on the distance from the shore, and exposure, different directions, and so on. So applying of those loads can get really complex if our structure is built of different structural members. Then also we have wave loads and current loads. So all the forces with different magnitudes apply to different elements depending also on the directions, also on the land, crest, amplitude of the wave. So applying all those loads by hand can be really tedious work and can take a lot of time. Then next thing which I mentioned is fatigue and buckling assessment. So maybe a couple of words what fatigue and buckling actually is. So fatigue cracks, maybe if we say it in more detail, are the small fractures, some small damage in the structure which develops due to repetitive cycles of loading. So whether it's working conditions, repetitive working conditions, or some load, like wave load, which is repetitive over a certain amount of time, the stress difference occurring in the structure can cause the fracture, the damage, starting in, usually it occurs on some connections like welding, where our classes, notch classes are lower. And this for sure have to be taken into account to ensure that the structure can be operated in a safe way for a long period of time, or the period of time which we assume at the beginning of when we create the structure. Then we have plate buckling, which is quite, I would say, one of the most serious damage which can occur in any kind of the plate structure where we have thin walled plates, and this damage occurs when our compressive force exceeds the critical threshold, and the member, plate, or flange of any kind of the structure loses its stability. So it can cause the sudden buckling, so deflection of the plate, which can even cause the collapse of the structure. So for sure, that has to be taken into account while doing the analysis. The next topic, which I already highlighted, is are the limitations of manual verification. So some time ago, everyone was using hand calculation, maybe spreadsheets, but this approach leads to high risk of human error. That's for sure. It's very easy to overlook some value, some coefficient, or maybe maybe just simply make an error while calculating some stresses, forces, and so on. So that's if we have one beam, okay, we can easily check it. But when our structure gets more complex, we have sometimes thousands of plates, thousands of different connection members. So that's almost impossible to do it without any error caused by human, by just simply overlooking something. Then the result of that is, of course, also the time, which the time consumption during all kinds of manual verification is huge compared to for example, checking the standard or simply checking stresses and deflection with use of FEA software such as SDC Verifier. Then one more thing is our load combinations. So as I mentioned, we have different loads acting on our structure. We have different combinations, different directions of load, operation loads, some exceptional cases which should be also considered, and it sums up sometimes in hundreds of different load combinations. Okay, we can do it by hand, of course. We can choose the governing ones and so on, but that requires again a lot of time. And again, we are prone to the human error. With SDC Verifier, you can simply apply as many load combinations as you want. I will, of course, explain it a bit later in details. And also, there is a possibility to find all the governing load cases, all the load cases which are the worst for a certain part of our structure. And then we can analyze, just focus only on them. So to save time and to figure out which conditions are the most critical. And last thing which I would like to outline is the representation of results. All types of spreadsheets, all types of different kind of manual calculations, it's really hard to represent nice results in a nice way. So with nice colors, outline the structure, the part of the structure which we would like to highlight. I would say it's almost impossible. If you take a look at SDC, we can simply choose the part of the structure which you would like to see. outline it, choose the legend, just the colors, view styles, and so on. So all these settings can be adjusted. You can create a template of your results and show it to your client or internally, just to easily understand what is the outcome, because that's the most important thing in verification. What is actually the outcome? Then we have our standards. So as I mentioned, all the structures which we analyze should be, there are some requirements for different kind of structure which should be met, depending on the also country, the type of the standard, depending on the industry, there are different standards. Also depending on different types of checks, so plate backlinks, or for example, beam member checks. Everything should, in order to ensure that the structure is safe, we have to meet the standard, and for example, in order to get certification on our structure. In SDC, we have a database of more than, I believe, 45 standards at the moment, main standards, which have, of course, different sub checks. And I think at the moment it's we cover most of the most popular industry standards, and not only for offshore. We have also standards for civil engineering, for heavy lifting, shipbuilding, marine design, and so on. So I think depending on type of the project you do, if your consultancy works with different types of projects, within one software you can get all the checks regarding all different kinds of projects. So that's for sure one of the biggest benefits of our software. Okay, so how SDC can help you to achieve all those goals which you would like to have, and design your structure in a safe way, and overcome all the issues which I mentioned before. What you can see on the screen is the diagram which describes the workflow which you can create in SDC Verifier. So as you can see, first of all, there is a simulation graph. Maybe I'll just take the laser pointer so you can see my screen, my mouse. So first of all is the simulation which can be performed either in our software, so SDC Verifier, or if you use add-ons, so for ANSYS, FIMAP, or SimCenter 3D, it can be we perform the simulation in the software and then do all the post-processing with use of SDC Verifier. But let's focus on our standalone version. So we can prepare mesh, geometry, import geometry also from step files or from any other files which you have. Then apply all the loads, automatic loads. I will maybe also explain it later one by one, and recognize the members, structural members, so all the plates, all the beam members, joints, welds, which have to be verified out of the model which we have. Then perform all the checks. So again, we have all the checks, not all the, but some major checks, the most popular ones here outlined. So we can analyze, verify our model if it meets the standard requirements, create automatic documentation, and also there is one more thing, we can perform structural optimization. So figure out if some of our members does not meet the criteria, what should be the section, the plate thickness, weld size, and so on, which we should apply, or how to decrease the amount of material which we already use if we see that the results are on the low side, then how we can save money with optimizing the structure. And the whole diagram is built in a circle because all this process is automated, and when you apply any changes in your simulation model, so whether it's you would like to revise some loads, some geometry of the structure, then you can simply update your report, and everything will be recalculated once again. So all the recognition checks and so on will be recalculated again, and your results will be up to date in a matter of a couple of seconds. Then the first part which I mentioned is simulation, and we can divide it into different types of actions we have to make. So prepare the geometry, meshing, and apply all different kinds of loads which I mentioned. If we go to the next page, in SDC we have possibility to create import geometry from the file which is already created, so for example step file, or create it from scratch, so with use of lines, surfaces, solids. You can prepare your geometry from zero basically, so you don't need to even have any other software to prepare this basis of calculation. Then once geometry is prepared, it's time for the meshing. So in SDC Verifier, we allow you to use different kinds of elements, such as 1D elements, all kinds of beams, shell elements. So what you can see here, for example, or the shell elements, and also solid elements. So depending on the complexity of your problem, you can choose if you would like to go for a simplified way or maybe more into the details. Also, it is possible to mesh your model directly from SDC Verifier. We have very huge variety of tools which allows you to refine your mesh. So for example, around openings, around some tough points where it's hard to do it manually, we have some automatic meshing tools. Also, we have an option to read the meshing attributes from your solid model. So for example, if you have a solid SDP model, SDC will automatically read the thickness of the plates and automatically assign it to the mid surfaces if you create them out of the model. Then the load combination loads which I mentioned. So we allow you to automatically apply all kinds of loads, so wind loads, wave loads, and so on, into your structure. Here on this short video, just let me play it. Okay, yeah. On this short video, you can see for one example how we can easily apply the wind load on the structure. So when any kind of the load in SDC which you would like to apply, you will see some window which allows you to set up some basic values, directions. So as you can see here, direction, vertical direction of your model. You can apply rule of the wind or wave and so on every, for example, 30 degrees. Then choose the attitude and the pressure from your database and create the graph of wind load and apply it directly to all the selection which you choose here in the window. So it works in the same way with winds, with waves, and buoyancy, and so on. Then next thing where we should focus on is the load combinations, and it's really easy to do it with SDC Verifier because there are several options for how to add them, how to create those load combinations. So maybe the simplest one which you can use is the combination, manual combination, where you can create, for example, template with your load factors depending on the load in Excel sheet, and then just simply copy and paste it into SDC Verifier window. So you use all the individual loads which are in the model and then combine them with different safety factors depending on the standard. There are different, of course, different partial safety factors which we have to take into account. And here, it doesn't matter how many loads that you create. All those loads that can be calculated for any of the check in easy and fast way, basically with one click. Then there is another option to create the combinations. These are automatic load combinations. So here, maybe I have short video on the next slide. So here, this is how you can simply add them in a couple of seconds. So all the individual loads which you create in the model are listed on the left. Then users simply have to apply the category to each of the individual loads. So permanent action, so wind, depending on the type of the load you have in the model. And then SDC automatically will apply partial safety factor depending on this category and create all those load combinations automatically. So you simply choose the standard for which you would like to do automatic combination and then apply it. As you can see here, we have a different database of standards. Simply apply it and all the combinations are made automatically. Of course, after all, you can adjust them. You can edit them. You can add a couple of manual loads if you need, if you have some combination internal rules which are not according to standard. So everything is possible in this case. Then I think one of the most important part of our software and in general of which we have to do before we go to the checks is the recognition. So as you know, structural elements are not checks are not done on structural elements. Are not done on finite elements. They are done on structural elements. So we need to know where are joints, where are beam members in our model, where are welds, stiffeners, and plates, sections, and so on. So with SDC, you can automatically recognize joints, so all the connections of your beam members, 1D elements, all the beam members itself. So SDC automatically reads the backing lengths depending on the different direction of the beam member, and then all those lengths can be used directly, will be automatically used in all the member checks. Then we have weld recognition. So for example, that's crucial stage if we want to perform fatigue analysis. As you know, fatigue damage occurs mostly on the welds because classification taken into account into fatigue analysis is much lower on the welds than on the rest of the model. So SDC will automatically recognize the welds, so all the plates intersections and the different connections, different properties. Same with stiffeners and plates. So in order to perform any type of buckling analysis, any type of analysis related to plates, we need to know the size of plate, thickness of the plate, where are stiffeners, how the plates are divided. So SDC also automatically recognizes all those elements and then apply different ID numbers. So during the analysis, you can simply choose it from the list. How it works in practice, got also a short video here. So there is a possibility to recognize separately all those members, but you can also click recognize all to recognize all those different types of elements in a couple of seconds. So as you can see, few seconds and we have already all of them. Then simply by previewing all those elements, you can highlight them in the model with different colors. So joints, beam members, you can plot them with colors with IDs, for example, to easily recognize which member is which. There are multiple different options for settings also. So all the members, like beam members, plates, can be automatically split, merged. So if you did some simplification in your modeling approach, then it also can be adjusted directly in SDC. Here you can also see how welds are recognized, and also connections. So SDC, as you can see, automatically can recognize where are cord braces and cord brace and brace connections in your model, which can be also used to perform the checks. As a summary, we can see all the plots. So as I mentioned, joints, beam members. So with different, each member can be highlighted with different color. Can be you can highlight also the ID number for each of the members, and you can easily recognize which is which. Same with plates and welds. Couple of few more words about plate recognition and panel recognition. So as you've seen on this picture, we recognize all of the plates, all of the panels, but sometimes when your model is huge, it's hard to figure out which sections you would like to analyze, which directions, and so on. So we also give you possibility to sort all the sections and all the panels by Z, X, Y plane, and also if there are any plates which are curved or not along the global coordinate system directions, they will be sorted as custom sections, so not aligned to any of these categories. So you can easily recognize them and show directly in your model only those sections along one plane. Maybe here at this moment I would like to tell you that during this webinar, for all the attendees, we have 3 dedicated demo slots available. So we can perform demo directly on your model. We can do the presentation just for you. So if you would like to book such a demo, my colleague will paste the link in the chat. So please follow that link. That you can directly click it and register yourself. Also, I would like to mention that if you would like to try our software on your own project, you can also follow the link to download directly the trial license and try all those recognitions and applying loads by yourself. Okay, so maybe let's move on to one of the most important and key topic of our presentation, which are checks. As I mentioned, in our analysis, in verification of structures, we have to meet certain standards. So basically, engineers have to figure out whether each part of the structure meets the rules prescribed by different industry standards. And in SDC Verifier, we allow you to perform all the verifications within one software. So any of the standards we have in the library can be added into the model tree, as you can see on the left, and results can be easily represented on the plot or with the tabular format. Moreover, all the checks which we have in our software are open, so user can preview all the parameters of the checks or the formulas together with all the descriptions. So it's really easy to find out how the checks are built, what each checks what contains, and moreover, we give you also possibility to copy check and adjust it up to your needs. So if you know that you would like to create, you have some internal rules which are using, for example, DNV standard, but you have some additional checks which you perform usually. So you can copy this standard and add your own formulas, or even write the whole standard from scratch with use of our tools. So as you can see on the right, all the formulas are done with different types of commands. So you can use other check results, characteristics, material data, constants, results directly calculated from your FEM calculations, so Nastran results, stresses, and so on. And all of those parameters can be combined into different formulas to form new standard or edit existing ones. So all those checks are open, and that's easy to adjust them according to your needs. But let's focus maybe on one of the standards. I would like to show you how to implement it in SDC and how we can easily show our results. So I would like to show how to add DNV or ABS standard, which are one of the most popular for plate buckling. So when you add any of the standards to your analysis in SDC, you will get pop-up window like this on the left or on the right. This one is for ABS, this one is for DNV. We can quickly compare it. So as you can see, depending on the standard, there are different options which should be filled and by user. So for example, material factor, resulting material factor, case on DNV it's 115. In case of ABS, it's by default it's 1, but there are also different values which can be used by user. So we give you possibility to choose it directly here. Then there is option to preview materials and yield tensile and yield limits of materials. So if you so for example, we can see materials with yield is equal to 0. That means all the materials have set up correct yield. If there is some error you forgot to set up, you will see it also here. So there is always a reminder that you forgot to fill some data. Then there is also selection. So selection which user have to fill so the selection for which you would like to perform the analysis. So for example, if you have very complex model, you don't need to do it for the full model. You can set only a couple of plates, couple of sections, and do check only for those plates, just if you need to focus on one place. And then for both of the standard, we have different we have settings of buckling parameters. And here we also give you some flexibility. So you can use plate average stress, or you can use elemental stresses. So depending if you would like to focus on your global plate results, or whether you would like to focus on your elemental, more local results, then you can also directly set it up from here. There are also a couple of settings about stiffeners, but maybe I won't focus in details on this. Of course, if you have any questions, you can always ask us about the formulas, about the approach, how we calculate it, and there is also a very handy help page where all the formulas, all the approaches are described. So as you can see here in the middle. Then when you present the standard different results from your standards, I compare them for the same loading conditions, which is of course not the ideal scenario, because we have different combinations for DNV and different for ABS. So As you can see, that's why the results are quite different, but that's explainable, of course. You can see that there is possibility to preview the results in a very easy way. So to show all the utilization factor for your whole structure for certain sections. So I selected one section here and here, so I can easily show all the values here. Of course, you can also preview them with tables just for every separate element to show separate utilization factor and all the calculation details. Then next thing which I mentioned before is the fatigue analysis. So fatigue is a bit more complex. Of course, don't get scared of all those tables. In fact, there is in fatigue check, for example, for DNV, there are 4 parameters to which you have to prescribe, and most of them are all the settings are quick. It's just you need to know where it came from. But that's not an issue. We always give you some details. So there is always description where you can find those standards in a check. So even if you're not familiar in some sort of the check, you can easily check it. So go to the, for example, use stress factor 1.2 for method B. Then you open it, you see you see descriptions with reference to the standard. So that means that if we use yes, then we have additional 1.12 factor for our method. And then the most important thing I think in the fatigue standard settings are SN curves. So we give you possibility to set up different curves, different classes of welds, and not only welds but also other parts of the model depending on the recognition. So we can apply it separately for intersections, separately for welds, butt welds, and so on. Maybe I will show it in detail on the next slide. So for example here you can see the classification, weld classification in X direction. So so as you can see in this table, which I showed on the previous slide, I can choose the selection for my classification and apply it directly, and then preview it in the model. So all those classifications are taken from the standards. So there is a table depending on direction, depending on the type of the weld, and so on. There are different classifications. So I can adjust everything here. What is important that all those steps in the table is actually important because we take into account all those steps one by one. So I set up for my full model classification B1. So as you can see here, B1, so all the plates are blue. And then, for example, all welds in X direction have classification C1. So we overwrite all welds from this selection with category C1. So as you can see, I have C1, all welds, yellow color, you can easily preview it. And then the lowest classification in the X direction would be on intersection. So I set up all welds intersection, category D, X. And as you can see, SDC automatically reads all those intersections here in all those detailed spots and automatically applies correct classification. So that's a huge time saver for you while doing that. Then similar case we have with weld strength in one Y, XY direction. It works basically the same. So you set up your type of the selection, welds, butt welds, and so on, and choose correct classification depending on the tables which are prescribed in the standard. And then all the results can be presented also with different ways. So overall plots, results only for welds, for example, some detailed plots with to show all the mesh connectivity, all the sizes and so on with detailed values, everything which would be appropriate for you can be shown in results here. Then there is few more things which you can do with SDC, which I mentioned before. So all kinds of optimization. We have beam member optimization, where you can set up possible properties for the beam, and SDC automatically will check which of those properties is the best one, gives you the best result. So for example, you can say, I want to have at least 80% of my utilization factor, but not more than one. And SDC automatically will calculate which of those is the best fit. Same idea works for plates. So you can prescribe what plate thicknesses you would like to consider. So from 8 to 25, let's say, L-shaped stiffeners, for example, size. And then SDC again will show you in the table which of those plates is the best for your design, so gives you the best results or meets the standards and so on. And the last, not least thing for optimization is weld optimization. So all kind of weld sizes, types of welds can be prescribed also, and SDC will automatically check your full model or the selection which you would like you choose, whether you can optimize some welds, some size of the welds or some types of the welds. Then at the end, when your project is done, we give you possibility to create template of report, including all the informations about the model. So you can highlight all the sections, all the material types, or the different properties of your beams, plates, and so on, and also combine it with different results depending on your needs. You can set up plots, you can set up views, so top, bottom, some detailed views. When you store it, it will be automatically updated after you do any changes in your model or in your analysis or check settings. So you set it up once, or you can also use our ready-made template where basically you don't need to set up anything. Everything is ready. You can maybe adjust something only up to your needs. Then you just regenerate it, and you save a huge amount of time on doing all the screenshots, copying, pasting. Then of course you can overlook something, forgot to update some photos, some screenshots in a report, which of course is always the pain point in presenting the results. Okay, let's maybe sum it up a bit. So this is what you can see on the screen are the graphs, the analysis made by one of our clients who compared the time which they spent on, for example, hand calculation, working with standard or reporting, and compared it to work with and without SDC Verifier in time. So as you can see, for all of those items, decrease of the time spent on the different kind of work is significant. Here on the overall picture, you can see that the time saving with SDC is at least 50% for the modeling, analysis, creating reports. So all of those steps can be also in your practice, in your company, it can be significantly reduced compared to what you do now, what you do with use of spreadsheets, with use of hand calculations, or connection with different softwares, because here with use of SDC, everything can be done within one software. You don't need to jump between different type of softwares. So again, if you would like to try it out, for sure, book a demo or use the link in the chat to download the trial version, and try by yourself if it can save also 50 or even more % of time for your case. Summarizing, SDC Verifier is all-in-one software solution. So we allow you to perform structural design, create a model, apply all the kind of loads which are needed for analysis, perform the analysis itself with Nastran solver or with use of different type of software and add-on of SDC on top of that, and then verify your structure for all kind of different standards to present the results in easy way and to automate your work, set up the templates, and then reuse it for all the different projects which you work on. Thank you for your attention. That's all from my side. Here on the screen you can see all the contact details, so whether you have any questions you can always contact us by phone, by email, reach our support, and yeah, feel free to contact me or our main email. I would say now we can move to the questions. So if you have any questions, please write it down in the chat. I will review it. So I will wait a couple of seconds for everyone. So if there are any questions, please feel free to ask them, and I try to answer everything. Okay, I can see one question. Is it possible to recognize plate panels intersections if there are any hole along the length of the panel, for example, holes for stiffeners? Yes, it is possible, of course. Maybe I will try to go back to my presentation. Let me see, I have appropriate slide. So for example, here we have some holes in the stiffeners or in the sections. So all the sections in SDC, we give you possibility to adjust the settings in a way that you can set up the percentage value of the plate which is covering another plate. So for example, if 80% of this plate is intersecting with perpendicular plate, it will be recognized as intersection. So there is possibility to set up this value. We call it dummy panel recognition or dummy stiffener. Also, it's available for stiffener recognition, and this can be easily recognized. So you don't have to skip those holes for analysis. Here they can be included also. And the second question, is it possible to compare different standards for the same structure in a SDC project, for example, in a report? Yes, of course, we can combine different standards. So as I mentioned before, we have a database of different standards. We have a database of different standards. And as you can see here in our model tree, all the kind of standards can be added into the one project. So you don't have to, I know in some of the softwares it's not possible. So you choose one standard and then you follow it for full time of the project. And here you can do it simultaneously. So you just simply select as many standards as you want. You can add them, analyze your same structure with the same loading condition on different standards. And then in the report, you can prepare different chapters for different standards and different settings, basically. You can even copy same standard with different settings. So that's also possible. Another question I can see, can we get a structural mesh from ANSYS and analyze in SDC Verifier? So there is a couple of options. You can import your ANSYS model into the SDC Verifier. So that's one thing. Or we have also an SDC verifier, which works directly with ANSYS mechanical. So as you can see, we work together with ANSYS, FIMAP, and SimCenter. So in this case, SDC works as an add-on to ANSYS. So you have separate ANSYS window where you prepare model, mesh, load, and then do all those checks, analysis, load combination in separate window of SDC, or you can also use it as an embed window directly in ANSYS. But for standalone version, so SDC Verifier, you can also import the ANSYS model itself. I'm just trying to see if there are any other questions, but I don't see anything. We still have a couple of seconds, so I can wait. If there is any questions, please feel free to ask. Can the reports from SDC Verifier be used for approval of the structural classification societies? Yes, of course, it can be used for approval. We work even with some classification societies like BV. So Bureau Veritas is using SDC Verifier itself for their checks and to test the standards and so on. So of course that can be used. We can in a report we have possibility to outline all the details of any of the check. So all the procedure of calculation is outlined, and that can be easily used to show it to classification societies, of course. Any other questions, maybe? Okay. I don't see anything else. So I think, yeah, thank you for your attention. Of course, if you have any other questions later on, feel free to ask it via email. Here are the contact details, so you can reach out to us by email, by phone, or submit the request directly from our website. My colleague pasted the link to download also the free trial version. And as I mentioned before, feel free to book a dedicated demo. We can do it on your model and show the capabilities of SDC Verifier directly on your project, basically. Thank you very much, and thank you for your attention, and keep in touch. Bye.